Welcome to Spring LIB.
Okay, we've got some statements and we've got to decide which of them are true about balancing equations. So the first one is if you have three molecules of reactant on the left side of the equation, let's say like H2O, HBr, and I don't know, let's say C2H6, that we have to have three molecules on the right. And in fact, this isn't true, right? So I don't know if it's immediately obvious, but the product of this is actually C2H6 Br OH plus H2O. Or it's actually plus H plus, yeah. Well, you could say 2 there plus H3O plus, right? And this is a totally valid balanced reaction that contains only two molecules on the right but three on the left. So just by the nature of this being a correctly balanced reaction says that no, this is not true. So the first statement isn't true. Okay. Next, if you have 5 of one type of atom in total on the reactant side, you must also have 5 of that same type on the product side. Now, this is true. So 1 was false, 2 is true, right? And that's what balancing equations is all about. You know, if I've got CH4 plus O2 going to CO2 plus H2O, for example, how might I get 5 on here? Let's see. If I have 2.5. So I think I'd have to do like this. If I have 2 methane, right, then I know I'm going to have 2 CO2. And I'm going to have how many hydrogens? I'm going to have 8. So I'm going to need 4 waters. And then the point is here that I would have 4 oxygens from here, and I'd have 4 from here, so I have a total of 8 oxygens on the right-hand side, right? This sums up to 8 oxygens. The whole point of balancing reactions is making sure I have 8 oxygens on the left-hand side by putting a 4 there. That's what we're doing when we're balancing reactions. We're making sure that the atoms on the left match the total number of atoms on the right. Number of molecules doesn't matter, but the number of atoms when we're done does. And you'll notice that when I did this problem up here, that yeah, we do have the correct number of atoms on the left as we do atoms on the right. So 2 is true. 3, a balanced reaction is consistent with the law of conservation of mass. And that's true. This is just a restatement of number 2, right? The whole idea is that we can't create carbon or oxygen or hydrogen out of thin air. So if we've got carbon or oxygen or hydrogen on the right-hand side, we've got to have the exact same amount, the exact same mass of carbon, hydrogen, and oxygen on the left-hand side. So 3 is just a restatement of 2, and it is also true. Finally, 4 is if you have 1 molecule in the liquid state on the reactant side of the equation, you must have 1 molecule in the liquid state on the product side of the equation. And I'm going to say that's false, and I will demonstrate why. Right? So, for example, if we have H2O liquid, we know that we can split this into oxygen gas and H2 gas. Right? There's no actual issue with this. Right? This is a perfectly valid reaction. We've got 1 molecule of liquid on the left and none on the right. But we know that splitting water into hydrogen and oxygen that's a real thing. You can do that in the real world. So there's no reason that the number 4 should be true. That is false. Okay, that's everything.